In this video, we're just going to go through 4 examples of using moles to calculate reacting masses. So hopefully you'll be able to give them a go yourself before checking the answers at the end. So here are the 4 examples for you to have a go at. Hopefully if you take a screenshot, or of course you can download this presentation from the website, and the link will be appearing, and have a go and then check your answers. So example number 1, we need to find out how much lead sulfate we will produce from 100 grams of lead nitrate. So the first thing you need to do is calculate your moles of lead nitrate. So you find your molar mass of lead nitrate as being 331.2, and 100 divided by that molar mass is 0.302 moles. You then look at your ratio, and luckily it's a 1-to-1 ratio between lead sulfate and lead nitrate. So that means we will have the same number of moles produced of lead sulfate as being 0.032. And then we just need to find the mass of lead sulfate that we are going to produce. So it's going to be the number of moles times the molar mass. Molar mass of lead sulfate is 303.2 times by 0.302, and you get 91.6 grams. For our next example, we are going to find the mass of potassium chloride, which I can form from 20 grams of potassium carbonate. So again, first thing we do is we find out the moles of the potassium carbonate, which is moles over molar mass, and we do that, we find it to be 0.145 moles. We then look at the ratio in the equation. By looking at the ratio, we can see that 1 potassium carbonate, we form 2 potassium chlorides. So we need to times our moles of potassium carbonate by 2 to give us 0.290 moles. And then finally, we're going to find the mass, which is moles times molar mass. Molar mass of potassium chloride is 74.5, moles is 2.9, and so we get 21.6 grams. So example number 3, we need to find out how much sodium chloride I am going to be able to produce from 7.1 grams of chlorine. First of all, we find the moles of chlorine, which is 7.1 divided by the molar mass of chlorine of 71. So we've got 0.1 moles of chlorine. Then I look at my ratio. It's a 3 to 5 ratio. So that means I need to multiply my moles of chlorine of 0.1 by 5 over 3. And that gives me 0.16 moles of sodium chloride being produced. And then to work out my mass, I times my 0.16 moles by the molar mass of 58.5 to give me 9.7 grams. So in this example, we need to produce 15 grams of sodium chloride, and I need to work out how much sodium hydroxide I require to do that. So first thing, we're going to work out my moles of sodium chloride, which is my mass over the molar mass of 58.5, gives me 2.56 moles. I then need to look very carefully at the ratio. You will notice that to make 5 NaCl's, I need 6 moles of sodium hydroxide. So I need to take my 0.256, I divide it by the 5 in front of the sodium chloride, and times it by the 6 in front of the sodium hydroxide, and that gives me 0.256 moles. Finally, to find the mass of sodium hydroxide, it's mass over molar mass. Molar mass of sodium hydroxide is 40, so that gives me 12.28 grams. So that completes using masses, reacting masses in equations, and we can now move on to how we handle gases in equations, which will be the following video.